Hello. Yes, Ignacio has a special if. Let's give people a couple minutes to get here, and then we'll start doing things. Yeah, so we dropped the compile time by 4% just this morning and by a lot of percent last night. See if we can get another 4% this session. It's possible. It's possible. Oh, I didn't change my I'm not sleeping right now. I'm going to take that off because it's noon. I'm just going to say, let's speed up the compiler more. Also, my computer smells like it's burning again, so the stream may fail at any time. Computer's making a lot of noise. I have no idea why. Like, what is OBS is running? Telemetry is running. Why is my computer working so hard? It's freaking water cooled. All we're running is OBS, and it's having a panic attack. Can I please avoid the horribleness that is the NPM node modules? Well, I don't know how NPM works, but we'll probably avoid the horribleness just through common sense. Do I avoid min and max? Wait, where? No. This is really old code. Dude, this code, it's quite possible. I mean, it's probably been rewritten a couple times since then. Some of this code in concatenator dates back to certainly past Braid, possibly Happy Cake, which would have been 2004, but possibly it's possible that concatenator was made for the Hover Tank game in like 1998, 99, 2000. Of course, it's been worked on a bunch since then, but like, I don't think it's actually that old. It must have gotten a complete rewrite at some point since then, but sometimes things are around. Maybe the thermal paste needs replacement, possibly. There is a C++ project being worked on next to Sokoban. Is Happy Cake the EDF like? Yeah. Ordinary Noctua heatsink and fan. Yeah. It might just be, like, I feel like there's something wrong. This computer was totally fine and quiet for a long time. And then maybe about a month ago, it started running the fan really loud and stuff. So, like, I need to either run, I don't know if there's a user level fan diagnostic tool or if I need to boot into the BIOS and look at fan temperatures and figure out what is too hot and so forth. The liquid cooling was pretty dope for a while, but now it's not any different from having a giant loud fan. Nothing obvious was obstructing the airflow, but who knows? When am I going to write my book when people ask me to get into the game dev? I don't know. I think most of these tips on how to get into game development probably are most valuable in the moment. I'm not sure that they have very much value as long-term comments. I talked about cargo culting in a previous stream. Could I explain how it affects programmers? How does it not affect programmers? Like, dude, almost no programmer really knows what they're doing these days. Like, if you're trying to write a program and you don't really know how a computer works, because you don't know how big your variables are in memory or whatever. You don't really know. You know kind of that a computer has RAM, but you don't really know what that means. But you're writing code that people run. How is anything that you do not going to be cargo cult? You just don't know what's going on. Well, 107, 111. We're getting pretty good numbers still. 104? We got a 104? Do I think the software renderer has a future? I hope so, but I kind of doubt it, unfortunately. I think if it has a future, it has a future in the GPU getting more programmable. And the reason I say that is just, as much as I would like to use CPUs to render, because it's just better, except in every dimension except for speed, it's way better to use CPUs to render. And I used to think that eventually we would ultimately be back in a CPU rendering time. The problem is, okay, we're moving toward a multi-core future anyway, right? So as computers get faster, because of all these limits that we're running up against, to take advantage of greater CPU power, going into the future, you have to be more and more parallel, right? It would take a really radical technology change to make that untrue, and it seems very unlikely that we're going to have any such technology change in the foreseeable future. So Right now, being parallel is where it's at. Now, if you have to be parallel anyway, if one of your tasks takes literally like 99% of your compute power, which is what rendering does in games, for example, and in most graphics intensive applications, the amount of compute power that's happening in the renderer completely dwarfs the amount of compute that's happening in the rest of the program. It's insane. Okay? If something is 99% of your actual compute, you want, and you need to have different processors running in parallel anyway, then it's a really good idea to have some of those processors be specialized toward the task. Because things that are specialized toward the task will be a lot better at it than things that are not specialized toward the task, right? So if you think of the GPU as just like more cores, but they're made for graphics instead of not, then it really makes a lot of sense, right? The only real problem with GPUs is that we have to program them through these really insane APIs, as opposed to the way that we program CPUs. If you could program a GPU the way we program a CPU, then the situation would be really good. But unfortunately, we can't do that on most platforms. How can I be so confident about the amount of speed up I can achieve? Because I just know, like, look at this. Look at this. This is how I can be. These are all the threads. They're just sitting there on my computer doing nothing, dude. If you can move this work into those threads, you'll compile a lot faster. Or, so that's the new way as of, the year 2002 to make your program faster. You can also do the old way of just make this a lower amount of stuff, right? We have both of those avenues available to us. And we have hardly even gone down either of those roads. So yeah, I mean, there's a ton that can be done. You just know, this is what I'm saying. Like, whoops, I just zoomed in way far. Like if you know your computer even a little bit, like I'm not a super good low level guy. I'm not like Fabian or someone, right? But I still know enough to know how little of my computer is being used right now. All right. If you don't know that, if you don't have a clear picture of that, then learn the little bit that you need to learn to know that, and it'll help you. It'll help you. Have I ever talked about how I do pseudo concurrent type checking for out of order declarations? It's just a dependency graph, like anything. It's not really, you wait until everything you depend on is type checked, and then you can type check. And in the old days, that used to be an explicit dependency list, but that was too conservative and caused problems. So now we just run the code to figure out what your type is. And if we hit something that we need, like if we need to look up an identifier and it's not, the type is not resolved yet, then we suspend. In a way analogous through a thread suspend, but it's not a thread, it's not a fiber, it's just returning from a procedure. How is the time of compiling smaller programs? Well, it's a lot less than the time of compiling Sokoban. I mean, I'm sure it varies per program. Generally, it's still dominated by the linker for smaller programs, just because the linker is a slow-ass butt. So, what can you do? Problem with multi-core is most people can't do it properly. That is true. That is true. You're right, I should close Discord if that's running. Make sure little of my computer is being used. It's hiding here in my little thingers. Let's quit the Tobii eye tracker since that's not running. I think we're officially, oh, let's quit the Epic launcher. That's probably making my computer go. Let's quit Creative Cloud. Let's quit this thing. Let's quit Steam. We can safely remove hardware and eject media. All right. Is a Hover Tank game along with the server currently available? No, and I don't even think I have the source code anymore. I had it at some point, because when we shut down that company, I think we both agreed to have equal rights to the source code. But I only used it to develop subsequent projects from, and I don't even know if the original code exists somewhere. Will I be able to get rid of the linker eventually? Yeah. Are there things that make the compiler extra hard to parallelize? I'm not sure. I used to think yes, but then I thought of some architectural changes that would be more parallelizable that we haven't done yet. But, you know, it doesn't seem so bad. We'll see. We will see. Oh man, my computer smells like it's burning again. I'm really worried. How does the LLVM backend hold up in terms of speed? It's pretty slow right now. Like, it takes 30 seconds to compile the game through the LLVM backend. But the thing about that is we literally just turn on all the optimizations. Like, I don't know if some of those are taking a long time and producing very little benefit. So, you know, there might be a lot of utility in picking like a somewhat optimized release build that takes like, you know, 5 seconds instead of 30 seconds or whatever. Have I checked the pump? I haven't. I literally don't know how to check it. I don't know how you check a water cooling pump. I mentioned that C++ is a terrible language. Did I mean both C and C++ or only C++? Well, so a lot of the ways C++ is terrible are unique to C++. I would say that C has some unfortunate decisions and a lack of modern features. Those aren't the same as being a terrible language, but I wouldn't choose to program in C going forward. Like, I use C++ even though I don't like C++, right? It would be nice if there was a way to just resume it from the same line with the same call stack, but I don't really know if there's a way to do it. There's this thing called set jump and long jump that you could use to sort of do that, but I don't think I recommend it. I think I recommend just being in control of your own stack rather than doing shenanigans like that, but you could try doing a set jump, long jump thing. I think the power supply is on the top of the case where it typically would be. I don't know. Maybe we'll do a stream later where I open it up and take a look. All right, let's start doing some things. When we left off this morning, we had sped up the compiler by around 4% by just taking out some of the dumb stuff that was in the symbol patching here when we emit the code. Wow, we still 145 plus 25, 170 milliseconds. Yeah, that's really too much for this. So we're going to keep trying to get this down. There's so many ways to reduce this number, by the way, at so many levels. Like, it's crazy how much faster this compiler can get. Anyway, one of the easy ways that we could maybe get some more speed is that one operation we're doing all the time in here is we're building up a buffer of bytes in this thing called the concatenator, which is a bucketed string, essentially. So you add more string, and then when you hit the end of the bucket, so that we don't have to do a big copy and reallocate all the time, as you would with a contiguous memory data structure. We just start a new bucket, right, and put more stuff in there. But when we're writing out the object file format, we need to tell it how far into the section a particular pointer lives, right? And then we need to write a pointer patch into a certain part of the object file. Now, well, to do that, we're saying, well, how far are we into this concatenator? And the concatenator, for speed purposes, doesn't keep track of how many bytes are in it itself. When you ask it how many bytes are in it, it starts at the beginning and looks at all the buckets and counts them up. And that ends up spending a lot of time. So like here we're calling concatenator length. And again, I think I showed this yesterday. Actually, we showed this in type table packer. We showed a lot of concatenator lengths, but let's look at these ones down here. In the beginning, if we zoom in, they're going to be real small, like 10 nanoseconds. I think 10 nanoseconds is like mostly, profiling overhead and error. Like that's very fast. I mean, anything. So we're calling it way too much. Where is it? Calling it 267,000 times when we compile, which is that's about as many allocations as happen in Chrome when you press a key. So that's a lot. But then as the buffer gets bigger, that overhead goes up. So like if we look here somewhere, we're 500 nanoseconds, right? So we're 50 times as long. So we want to replace this with something that's fast. Maybe eventually we could stop calling it so much. There are ways we could think of to not really call it. But as a first step, while we're calling it, we could just make it a lot faster. They fixed that part of Chrome. Yeah, I know. I thought of that when I was saying it, but it's, nobody ever probably even measured that for Edge or frickin' Firefox. Okay. So we're going to do a length, right? And here's the thing is, let's leave this comment because that's still true. Frickin' size T my butt. All right. That's how old this code is I still used to put void in my 0 parameter routines. Lol. The thing is, we really don't want to get this length wrong. And we're going to do a new thing that tracks the number of bytes in a different way. And what we're going to do at the bottom of length here is we're just going to call length new and then assert that they agree. Right? And then once that assert doesn't go off, we'll feel good about where we're at. All right. So we're going to say length new, and we're going to say other, auto other is length new. Assert tally is equal to other. All right, so length new. Well, we're going to say it's going to not have a loop in it. We're going to say length before last plus last point minus last start. Okay, so every buffer has a point, which is the next place that new bytes will go in, and it's just got a start, which is the start of its data section. So this is the number of bytes in the last bucket. And then every time a bucket stops becoming the last bucket, we're going to put into length before last. And we're going to make this U64 because screw it, right? Size t is dumb. Right. So we delete all this old stuff. So we need to do this length before last situation. Well, what is it? We're going to say U64 length before last is 0. And every time we cycle a new block, I don't know if that's still called cycle new, or if we steal, you got to worry about stealing. All right. So when we call ensure space, okay, we call expand. And that is not in the header file because by the time you're expanding, it doesn't really need to be that fast. Okay. This is a victim of a long ago search and replace. Okay. So we make a string bucket. We say length before last plus equals last point minus last start. Definitely steal also sets last. Reset length before last equals 0. Okay. So definitely steal, that's the thing we added yesterday. This is where it maybe gets a little tricky. So we can end up in this weird situation where last is almost empty. We could even have last be completely empty and end up, we could have last be completely empty on entry. If that happens, well, we wasted a bucket since we do not check for it here. Okay. So this is when you've got another concatenator and you want to chain the buckets together without copying anything. Why are we saying bucket equals bucket next here? That's so weird. That's wrong. I must have pasted that out of some code a long time ago. Okay. So length before last is that. And then, so there could be an arbitrary number of buckets in this guy. So we're going to say actually, we'll just say, okay, here we go. Auto cursor is last, right? And then we do this stuff, and we say while cursor is not equal to last. We have to put parens here because it's C++. While cursor is not equal to last, length before last. This is cursor. And then cursor is cursor next. So we leave the cursor on our old last bucket, and then we keep going until it hits the current last bucket. Right? And then we're going to run a debug build if this compiles. Should have just compiled the debug build so I don't have to wait. At this point, this compiler is substantially smaller than the frickin' Sokoban game, and it takes so much longer to compile, because that's just what we're dealing with. Okay. Oh yeah, robustness comment. That's a good point. Eventually, this is just going to be length and not length new. Of course, now I'm going to recompile the whole frickin' thing because I deleted that comment. Okay. Well, let's hope we don't hit an assert. Or let's hope we do. If we do, that's progress too, because we find the problem. If we don't, hey, we didn't assert at all. Let's make sure that code is activating. If we get spammed by yays, by 300,000 yays, then we know we're good. Well, you didn't get any yays. Did we have a Visual Studio dependency problem where it didn't really compile it? Dude, I frickin' hate this compiler. It might have just like not really compiled it before. I'm not really sure what's happening now. Let's just run from the debugger. Did I like correctly? Oh, we ran the release. Wait. No, it took 6 seconds. That must have been the debug build. Dude, this is why I insist on full builds all the time. Because when this kind of stuff happens and you're just like, what just happened? Well, we just ran. We just ran successfully. So maybe this printf is messing it up? Is this triggering our Heisenbug in some way? That would be interesting. Let's just see. We're triggering a different bug? That could be an interesting sidetrack. Just to put a sleep there and see who is unhappy with that. Dude, I don't even know what just happened. Like, why would printf yay, which hasn't even happened? Like, we haven't got any yays. All right? Let me make that clear. We put a new line, so it should be flushing. Like, why is that giving us an assert? Line 272. Okay, so we returned length. It somehow didn't assert that the numbers were different. And we returned the same. This is a compiler bug or something. Like, we didn't change anything here. Current section start 0. So base address is whatever we got back for length, 44 in hex. So that's 68. That is not 0 mod 8. That's true. Length before last is 0. We're getting yays in our oh my God. Concatenator has a method called printf, by the way, everybody. Okay. There we go. We got a lot of yays. That's all I wanted to see. That's all I wanted to see. Okay, so we're going to delete this. We've got length new is now length. All right. Casey's howl of shame. That's not really, when they're that funny, when a bug is that funny, it's just, it paid its own way by being entertaining. Like, dude, I haven't used concatenator printf in forever. We probably should take it out. Because, like, I don't really use this for text stuff now. Maybe I do. Not in this compiler, though. So I just forgot about it because I don't use it. All right. Look at that. Look at that total time. Let's hope it actually runs when we try to run it. Oh, we're over. Oh, we're over. Under 1 second. It's opening a window. That's what happens when you don't call concatenator printf. You get under 1 second. That was a much bigger speed up than I expected. I did not expect to be under 1 second with that one. Now keep in mind, we're still kind of wastefully calling length. So in a lot of these cases, like for example, if we're writing in type info structs, we know how big each one is. So we could just keep our own local integer and not have to ask the concatenator all the time. It might not be that much faster, but it would be faster probably. It would be a little more code and a little more tracking in individual places. Maybe we don't want to do that. What was the time before? Well, yesterday it was 1.65 seconds. Then by the end of last night, we got it down to 1.11, I guess. And then this morning, we got it to 1.07. And now we've got it down to, And these are not hard optimizations. You saw, aside from the printf little fiasco, that was a relatively easy and non-invasive optimization to perform. So we're still... again, when someone asks, how do you know that you can speed up the compiler that much? It's because a lot of what the compiler is doing is stuff like what we just did. And yet, it's still faster than most other compilers. What does that tell you about most compilers? They're sad. Sad. All right, so we're under 1 second. That's respectable. Let's run the tests and hope we don't fail them horribly. It might happen. We still haven't fixed our Heisenbugs, so they might fail eventually due to a truncated file name, and we expect that. We're not happy about it, but we're delaying our fix on that so that we can do work in another direction. Yeah, 10x speed up is the plan. Maybe it's time to investigate motion sickness on the witness. I don't know why people get motion sickness from the witness, dude. We tried. I tried, and I just don't know. I simply don't know. There's, could be anything, man. All right. Let's just do a telemetry and look at things. I have the feeling that whether I have proof that it shows up on the profile or not, I'm going to want to go through and change all those array stack ads to non-stack ads. Even though, again, that probably doesn't matter that much, we might as well do it. Just for principle's sake. And I have several to-do list items here that are to do that in different files. So that'll enable me to remove those. But first, let's do another one of these. All right. Telemetry. Beep, boop, boop. Okay. Let's close the old ones. 7:12 p.m. That is our new one. Timeline. Look at that, man. What's happening out here? Like this thread ends? Oh, this must be like telemetry shutting down. Out here or something. Because we're done at this point. Are we? What? How long did telemetry take? 1.09? Yeah, 1.09. This is a 1.1 second mark. So yeah, must be telemetry flushing its data and shutting down. Anyway, so this is where we do all our work. For the main program, this is the meta program compiling and stuff. That takes 80 milliseconds now, which is maybe longer than I would like. Well, okay, yeah, dude, this is down to 80 milliseconds. Didn't we just say that was 140 or something? We own that situation. I wonder what all this is. What are these? Whoever's calling compile, this is enough time. It's 15 milliseconds. I don't know. We'll investigate that. At some point, after we do enough stuff, this will become a large part of our time, and then we'll be like, what the hell is that? So pack data for type table takes 5 milliseconds. Only, wow, that got a lot shorter. But again, even this is doing way more work than it needs to. And well, more to the point, it's outputting much more data into the executable than it needs to. And so we will be able to cut that down even substantially more. Yeah. These are pretty small. Again, anytime you get down to like 10 microseconds, it's like, I mean, I'm sure we can optimize it, but it's not really the most productive thing to try to hit right now. And why am I saying Lambda body output machine code? Like, that's really the only time we output machine code is for Lambda bodies. So that's a redundant name. Oh, we got some modify 4Bs. Look at all those. But that'll only say, see, now we're down at the point we can try to kill those modify 4Bs, which might be worthwhile, but it's going to save us like 2 milliseconds. It's like, yeah, we could do that, but 2 milliseconds? What's at the top of the timing table? Do you mean like this? So we're sorted right now by time used in your own procedure body. So type checking, no surprise. In fact, that's 260 milliseconds all inclusive, right? Actually 350 because this is one above this. Now, why this has 80 milliseconds of self time, I don't know. We maybe want to look at that. Do export, which is the thing that gives data structures to your program, is big. But I feel like we're just going to try to parallelize that later. I don't know how much I really want to try to optimize it, because the thing is, we want to keep it really flexible. We could look there and see if we're doing anything really dumb, but we want to keep it flexible because, you know, the format under which data is given to your program is really under still heavy evolution, right? And we don't want to do anything to make that harder. Just send me a Twitch whisper about the motion sickness thing, and I'll take a look. Or a message. You can send a private message to me on Twitch. It's fine. You know how many A to D conversion you can do in 2 milliseconds? A lot, yeah. Why is do export so big? Isn't it just basically serializing from internal data structures to user space structures? Yes, there's a lot of data structures for your code. Like you know, we have 100,000 lines of code. I mean, we could look at why it's so big. Maybe there's something dumb there. Maybe we're doing some modify Bs or whatever, but what color is that? It's a yellow. Let's send messages. Are our do exports in there? Yeah. I mean, like you recursively navigate the whole tree, and it just takes time to do that. I don't know. I mean, I say that, but there could be something real dumb. We can go look at it for a second. See if we see anything further to profile. All right. Yeah, let's take a look. So, you know, each queued thing is one of these things that's getting handled asynchronously by the compiler. If it's like polymorphic or it failed to compile correctly, we don't pass it. If it's a procedure type, I don't think we need this anymore. This check. Maybe we do. I'm going to make a comment there. Okay. So this is the thing we're going to pass to external code. We say do export on the expression without. I don't think we need to do this. I don't think. Yeah, because we called new. That's old and no longer applicable. So what we're doing here is we're making the format uniform for the external program. Some things that come in are not declarations, but to the external program, we just say, look, this is a declaration, just so that you can always expect a declaration. It's just to make things easier on people. Although, who's to say if that's actually easier? We need to see. And then we export notes. So the flattened nodes is sort of what we pile up. Okay, this is questionable. We'll talk about what this is. When we export stuff to user level, we flatten it into an array because we're like, hey, if you just want to search for an identifier or whatever, you want to search for some expression type, then rather than having some recursive visitor thing that needs to understand all the expression types, you can just look for it in this array, you know? That's convenient, but if you didn't want to look for it in that array that way, you're paying for that now. So I'm not actually sure if it's a good thing or not. I don't know how much it costs. I don't know if you should. I mean, if we do it this way, it's probably still faster than if you do a visitor and user code. Maybe it's a flag that you could turn on. I don't know, man. I don't know. Um, these are just the questions of life that we are dealing with here. Okay. So let's look at do export for an expression. Yeah. I was working on New Year's last year. Probably be working on New Year's this year. So we just switch on the type and then we do things. I mean, you know, we're exporting trees. Like this, it looks like it's always called from methods. So I think we can do that. I don't think we use that. We use it in interp. Okay. Maybe we use, let's see if we use code message get anywhere else. Nope. Okay. So that deletion that we just did is valid. I don't know if that costs us any time, but it might cost a very little bit. And you know, sometimes you just got to squeak out little bits until the non-little bits like crunch closer together and then you can see them better. Why is this a frickin' lambda? Why did I do a lambda? What was I doing this just to do it? Like, so that's all used externally here for compiler messages. There's not that many compiler messages relative to, because one message should contain many, pointers to many declarations. We could measure that if we want, but right? We just wanted to be able to do a sequence where we knew it, and then, you know, we set some stuff. I hope that inlines. Yeah. So our last telemetry run was 109. Wow, dude. Our non-telemetry runs yesterday were 165, so this is great. This is so great. 111. Yeah, so no real speed difference. 112. In fact, it's slower. Congratulations. No, it's not really slower, it's just noise. Well, I doubt it's slower. So I'm not really seeing anything obvious to hit here, which is not to say that there isn't something. Like last time, a long time ago, when I looked at the object file stuff, I was like, I don't see anything obvious. And then we came in the last couple days and like really kicked its butt. But I don't see anything here right now. I want to go back to the object file thing and check some of these things off my list of the stack initializations, just because I'll feel better about it. Do I have a perpetual license? No, I pay for it. It's expensive. If you ask them for a discount as an indie, maybe they give you one. I don't know. Don't tell them I asked or I said that, but it's expensive. But you know, when we use it, we get a lot out of it. So. What do I think about having the option of making unique tokens out of strings at compile time? It would be nice for naming UI elements. Well, you could do that. Just do compile time execution, make a token. So I think I could get more cache locality by having syntax tree nodes in a buffer and referenced by index instead of full 64-bit pointers. Well, it's possible. It's possible. That's just the realm of stuff that I wouldn't worry about right now. Because I don't think we're anywhere close to that being our speed bottleneck. But once we really got down to it, it's possible. The thing is, you know, now you're imposing a limit on how large an expression can be. I mean, you know, 4 billion nodes is a lot, so maybe that's fine, but what does telemetry do? It is a profiler. It gives you a visual representation of how long things in your program take to happen. Jeff needs another boat. Jeff doesn't even have his old boat anymore. He sold it. Or maybe he sunk it in the lake. I don't know. Can't afford all the boxes of bananas. Oh, if only you knew. He has an Amazon Alexa at his house. And Casey and I were over there recently, and we kept saying whenever Jeff wasn't around, Alexa, order bananas. So it was pretty good. I don't know if it actually ended up in any bananas being ordered, because I think it goes into a queue that he has to vet, but okay. Um, how long is type table packer taking these days? Because we're going to go there and do this. Pack data for type table 469. Milliseconds. So anywhere where we go .add, well, that's an array of integers, so we're not really going to do it there. Well, auto. Oh, before we do this, have we checked in? Let's check in. I feel like we haven't checked in for a while. Sub 1 second compile for Silverbaum. All right. We're going to say auto patch. Well, we'll keep the type just for documentation. Equals general local pointer patches dot add uninitialized, right? Auto to emit is strings to emit add uninitialized. Oh. Okay, here's the problem is add uninitialized doesn't run the constructor for these things yet. And so at least I don't think it does. Did I do that? No. It is literally uninitialized. So in some cases, we may be relying on things being initialized. Let's not make this be add uninitialized. Let's make it be add and return pointer. All right. Okay. So how the hell do we do placement new? We say like return new result t. That's so stupid, dude. Is that, somebody tell me if that's right? I don't even know. All right. Would it be nice to have a colon star equal operator where you infer the type but make sure it's a pointer? Possibly. There's other versions of abbreviated colon equal that might be even more useful than that, though. That's on a list of stuff we're going to think about at some point. Okay. So we were in here. Oh, great. Okay, add and return pointer. Really? We didn't have that much in here. We're just adding integers all the time. Oh, arrow add. Yeah. Okay. Well, let's make sure we didn't screw something up. And then we'll do those strings to emit. All right. Well, ta-da. Okay. Okay, to emit, return pointer. All right, to emit arrow string equals s. Pointer location in buffer. We might want to do that at some point. Let's say, just to give that a local variable. Although that's going to be U64 to S64. We're going to get, maybe we should make length S64. Because we're yeah. Just, I don't know why I broke my rule of being signed everywhere, but it's a good rule. So we're going back to it. One, 99, 99, 99, Brooklyn 99. Okay, great. What was I doing? I was back here. So we were doing this. I mean, even this stuff, like, I'm sure this add U8B is really slow, right? No, except the thing is, this is an unaligned right, which might be slow in some, I don't know. I don't know. I don't know. Okay. All right. So this other add, how big is the general local? That's only one frickin' thing. Let's do this one. Strings to emit. To emit is strings to emit, add, and return pointer. Okay. To emit string pointer location in buffer. All right. Okay. Let's make sure that works. I'm sure that that was a negligible or zero speed up. We certainly seem to be in the same neighborhood time-wise. But I just wanted to do it. So now we're going to do that in the OBJ writer and the x64 converter. Okay. Yeah. X64 converter. Look at all these. Look at all these frickin' stack ass copy. Jesus. I'm not sure about this debug context. We're just going to have to audit these. So these, and return pointer. All right. I'm just going to get compile errors for all these and then fix them. That's how we're going to know what to fix. Okay. All right. Well, we did that for x64 converter. Let's hope we didn't break the program. Could happen. Still in the same general neighborhood. Like I said, I don't think this is a big deal. It's just, I want to feel good about it. I want to feel good about it and get it off my list. Okay. OBJ writer. The hell is... I think I don't do this very often. We don't export. Maybe we do export a lot of symbols. I don't think we do. Section header ELF. Let's not worry about that. String table. There's really, yeah, I wouldn't really worry about these. Well, that's that. So well, I think that brings us to the end of that line of investigation. So we didn't really buy any more time there, but you know, it's fine. We didn't expect it. So I think we go on to the next thing, which again, it may or may not be something that buys time on the clock, but it's something that I'm thinking about will help with parallelism. I'm going to heat up some tea water though before we do that. Are there any questions about what just happened? On topic questions about the programming that just occurred? Questions? Come on, window. My window is being annoying and hard to deal with all of a sudden. I don't see questions. 400 people, no questions. That's fine. Why is my always be signed rule important? Because you don't want to spend a lot of effort trying to figure out what to cast to what or whatever, right? And if you're unsigned and you don't realize it, you can do things like subtract two things that you expect to yield a negative number and not get a negative number, right? So unsigned is a little bit dangerous. It's not that dangerous, but and you know, the reason to have unsigned is so that you could fit a bigger range of numbers in cases where you have a limited number of bits, right? But the amount of time when that's actually a situation is not that often. And so it's worth making it very explicit when that's what you're doing, and otherwise having all your indices be signed. You know, they'll auto cast up to larger sizes just fine. And, well, I don't know. It reduces the cognitive load of what you have to think about, right? So in that case, you know, we had a 64-bit length variable on the concatenator, and it's like, look, we're not going to need the top bit of that 64-bit number. That's just not going to happen. So just make it signed, right? You don't need, yes, it's true the length cannot ever be negative, but Well, first of all, if you ever do see a negative length, that tells you that memory got corrupted. But also, um, I mean, I guess you would know that if you saw a ridiculously large length. So that's not really anything additional. But yeah, I don't know. Everything that I said, simplicity and clarity. Is anyone testing every once in a while if everything in the compiler works in Linux? Yes, I believe at least one person on the team works primarily in Linux. Primarily. How often do I have floating point problems? Not often. It's very rare. Well, what do you mean by floating point problems? Documentation site will be up before Christmas. What's the URL? I don't actually know right now. I will know when I go dig out the email and get off my butt and do the thing that I need to do for it. Okay. Let's do one more look at the telemetry numbers. And maybe now that we've gotten a bunch of low-hanging fruit out of the way, it's time to think a little bit about more serious structural things. I don't know. We'll see. Anyway, I like how much smaller this got. This used to be, like yesterday, twice as big as it is. You know, this is the object file generation. It's still, again, it still probably could get a great deal smaller, but we're not going to worry about that right now. We could probably do some other good elsewhere. I want to look at some of this stuff up in like parsing and whatever. I'm not even sure what I have instrumented right now. Yeah. So there's all these like atom table resizes and see that's just one of these arrays. All right, let's talk about the way things are structured right now. One of the decisions that I made very early on. What are these? Heap array expand. Yeah. One of the decisions that I made very early on that seemed smart, and in retrospect does not seem so smart. Uh-oh, my T might oversteep. Hold on. Hold on. Let's make sure. You want to learn C, C++, Java? Do I have any advice? Pitfall? No, we just do the stuff. There's no, don't overthink it, man. Okay, not oversteep yet. So one thing that I did that I thought was smart was like, hey, anytime we're parsing and we parse an identifier, then we can register that identifier in a global atom table, right? And then we won't have to do string compares if we ever want to like look an identifier up in a scope. Like the atom table just contains a structure that points to the canonical version of that string. So anybody with that same identifier has the same pointer, right? The word atom comes from Lisp. It's not really meaningful in this context. It's like whatever. It's just a canonical place to look for a name, right? Now the problem is when you're trying to do stuff in parallel, then adding things to that atom table becomes a point of contention, right? You have to synchronize the table, or if you want to look something up in the atom table, right, you have to take a mutex on it. And that's really not the best thing. And as it turns out, string compares are not going to be that expensive anyway. So first of all, we store strings as, well, I don't know if we store them in atoms this way, but we could store them as length plus data. So first of all, most string compares would fail on length failure, which is just an integer compare, right? And then if it didn't fail there, well, we either could do a byte by byte comparison on the data, or we could compare the hashes that we already make to put things in the atom table. We could just maintain those hashes. And in fact, we could compare those first, and not the length, because, you can think of lots of evil cases when lengths would inappropriately match because you have a bunch of variables of the same length. But anyway, you could do a relatively quick integer compare that weeds out almost all cases, and then just do a regular string compare, which at that point is not going to be very slow. And I suspect that all of that would, in general, be a lot faster and a lot nicer than having a global atom table. And the really good thing about that is, I think, once there's no global atom table, then all these lex and parse threads can run in complete parallel. Like right now, it looks to me, it's hard to say because I don't know what's instrumented, but see how these are like, well, these are, I don't know. Anyway, I don't know what's instrumented here, but it could be the case that a lot of people are waiting on a lot of other people. Like here, we're waiting on a semaphore here. We're waiting on a semaphore here. I should make those a different color. This could be us waiting for another job, or it could be us synchronizing on the atom table. I'm not sure. It's probably us waiting on another job. Yeah. Anyway, it's hard for me to visualize right now the amount of contention on the atom table. So I want to reduce it by removing that global thing, because here, okay, so here's the basic thing about parallel programming that people don't seem to understand. Oh God, now my tea is totally going to be oversteeped. That's what people don't understand about parallel programming. It's just like actually getting your threads to run at the same time is pretty hard. And if you ever have synchronization, it'll bite you pretty often. And synchronizations will snowball, right? Like say you've got a global data structure and two people want to write it. Well, the second person is waiting for the third person for the first person to write it. Well, some third person is probably waiting for that second person to issue a result, right? And a fourth person is waiting on the third person. So like everybody starts log jamming anytime you have a synchronization, right? So you want to avoid all synchronization anytime that you can. And that's just a fact about this. If you never remove something from the table, you could optimize it by not locking it all via mutex, but combining copy and swap with a version integer on the list. That is potentially true. I still would like to not maintain a global table, though, I think. I would rather try the version that has no global table and nothing complicated to think about than the version that does and is trying to be fast about it. Because again, I haven't done enough lock-free data structures to really visualize how this would work. But don't you generally have to like retry if you are trying to do something at the same time as somebody else? I don't know. Like, I guess you could do a thing where you reserve an index by atomically incrementing a variable, and then nobody else will touch your index. And as long as you're not going to cache stomp somebody else, like, that's fine. But, you know, that's very simple as long as you don't need to get more memory and stuff. But what happens when the table needs more memory? Who's in charge of that? I don't know. So yeah, I want to do the simple thing first. And then, so it might turn out that I do the simple thing. But then later on, we decide that string compares are taking too long. And then that would be a reason to go back and do a global table again. But we've had a global table for a while, and I would like to try and not having one. We would still have an atom table, I think. Well, maybe not. I mean, maybe we just don't do that. Maybe we just don't have global atoms anymore. Anyway, so I want to review to make sure I didn't already go some direction, right? Because I might have done some work in this direction. I don't think I did, though. So we have this data structure called atom table, which is just a hash table that's just hard-coded, and it's for this case, and it's not very big. You know, it's pretty simple. Not a lot of code, not a lot of data. It's a hash table. And I think we have Robinhood hashing turned off because I think we decided that Robinhood hashing sucks. Sorry, Sebastian. I forget why, but there's some reason why Robinhooding doesn't really help you if your hash function is good. Okay. Jeff can explain it, actually. I think Jeff did a lot of work on Robinhooding. Okay. Yeah, you know, it's interesting. I've done actually very few. It's been a long time since I did lock-free data structures. And I should actually do that some because, you know, we're going to start doing threading primitives in the language soon. And, you know, they're not going to be anything fancy, but, you know, to the degree that you need locking and fences and stuff at the operation level, we want to do something good there. And I need to go to the weight room and lift weights. I need to lift some lock-free data structure weights and do a bunch of reps so that I know what I'm talking about there. You would really like to know the details about how Robinhood is bad. You're not talking about tombstones. You can do Robinhood without those. I honestly don't remember. I don't remember. Jeff had a really good explanation. He did, I believe he did a really thorough performance comparison of Robinhood versus not on a wide field of data and came to the conclusion. He observed that it's not worth it. And he explained it, but I don't remember. Okay. Anyway, I could turn on Robinhooding for this hash table. I made it work and debugged it. It's just, ugh. It's not very much added code. Like it's, you know, it just complicates what you have to think about. And I guess that probe distance, yeah. So we might just delete that. Anyway, so right now there's an atom table and an atom table mutex on the main, is interp is the main data structure for the compiler, right? So we have these things and, oh, bro, I did do some work in this direction. Lexers have their own local atom table. And then I think we merge it with the global atom table later on. Because I was observing, right, I was observing a lot of contention when you were randomly grabbing atoms. So I said, look, we're going to have a local atom table and then we'll merge. So let's look at, oh no, okay, right. Okay, all this is, it's not even what I said. It's not that we make a local atom table and then merge. It's stupider than that. It's anytime we succeed in making a global atom, we also make our own atom. And the reason is we just use that to remember that there is a global atom so that we don't have to take the lock again, right? So it's like a local shadow of the atom table for any atom that we're referencing that allows us to not take the lock, right? So we just say, hey, let's get let's do this hashing, whatever. Look it up in our atom table. If we found it, return it. Otherwise, whoops. Otherwise, do this. This is potentially expensive because it synchronizes, right? This is the thing that puts this in the global atom table, and then we do this. All right? Okay. So what I would like to do is make it so that we don't care if it's global or not, right? We want to change identifier comparisons so that they no longer compare atom versus atom, and that might spread to more cases in the compiler than we expect. So what I think I want to do is I want to overload operator equals for pointer to atom and just make it fail, right? And that'll make me replace, like I could overload it with something, if I was a modern C++ person, I would overload it with something that did my alternate compare method, but like that gives me the heebie-jeebies. I don't want to overload operator double equals with something weird. So I'm going to use a temporary overload to make it fail anywhere that I'm comparing these things and hope that that catches all the cases. And we'll just replace them with a call to some routine that we're going to say compare atoms is going to be our routine. And compare atoms right now is just going to compare the pointers anyway by casting them to void star, so that we get around the thing, but later on we won't, right? So how do I make it fail at compile time? Like if I make it a template, I don't do enough C++ templates to know this, but like there is a static assert in C++ now, right? So if I go something like just way up in my header file, if I say template type name T, bool, I don't even remember how to do this. Is this how you do it? Do I have to put parentheses around the operator equals? Dude, I don't even know. And now, so I've said this is a template, and the only reason I've said this is a template is because I don't want it to evaluate unless I use it. And then I want to say like static assert false. I don't know how that works. Oh, equals delete. They put in a crazy syntax. So you guys are saying I can do this, and that's actually a thing? Dude, C++ is so messed up. Like they literally had to reuse a keyword that has nothing to do with this. This is like a 12-year-old made this up. No, not it's not that bad. It's not that bad. Sorry. It's I can sort of see the mindset that you would be in to make this work this way. For operator, the template parameter needs to be deducible from the call arguments. I see. Equals delete. If overload resolution selects a deleted function, then the compiler will give you an error. Okay. Yeah, I don't have any problem with this as a feature. I just think saying equals delete is really weird. That's the only, like, you guys really couldn't think of a different way to do it. But whatever, I'm fine with it. So this should cause us to fail to compile in a number of places. Oh, we don't have Atom yet. Operator equals must have at least one formal parameter of class. What? Of class? Like it can't be a struct? Is this something to do with equals delete, or is this something to do with operator? Equals format C:. Why is this not working? Can't have pointer to... Why not? What does a struct have to do with anything? I literally have to make this class and say public. Is that where we're at in 2019 with C++? Oh, don't they take references? But what I'm comparing is the pointers. Can I not do this for pointers? Pointer and pointer are considered like primitives as if you were overloading int and int. Okay, can I do that or can I not do that? You can't. Someone's saying I can't. Time to write an LLVM pass to catch everything. Yeah, dude, I don't know, man. Like I almost, like in my language, I would just write something in the metaprogram that searches for compares between atoms, and it would be kind of trivial. I don't know how to do it here. Now, someone is saying that you can't actually redefine operator equal for primitives anyway. Like, I'm not comparing atoms by value, I'm comparing the pointers in the program. And someone is telling me that you can't overload that, and I believe that. I mean, I'm not sure it's right, but I believe it. You're confused about the pointer thing. You thought I could do that. Someone is saying try it with references. All right. I don't know that that's going to matter. Oh. Must have at least one formal parameter of class type. Yeah, I think what this is trying to say, it's really maybe an error message that could be more human in the way it explains. But it's saying you can't overload things on primitives. It has to be defined inside the structure class, but it's not, we're not trying to overload on atom, we're trying to overload on atom pointer. So we can't do it, I think. We can't do it. Your research online suggests there is no way to do this at all. All right. So we're going to maybe be sad. We could search for every instance of double equals in our program and audit them for atoms. I think what we do is we get the obvious ones. Okay, so the obvious ones are when we look up names in scopes. And then there's a few things like on interp, we have some atoms, right? And we use these for compares. And so we can search for these variable names, right? We can search for these variable names. So if we do that and we do identifier lookup, and we search for name double equals, that'll get us most of it. And then I think we may still have some bugs after that point that take 100 years to find, but that's how it'll be. Atom pointer with overloads to make a pointer behaving thing is the only way to do this, you're convinced. Yeah, I don't want to do that. I don't want to pay for that. It's your fault for using raw pointers to begin with. Well, that's why I'm getting off C++, because of that attitude, exactly. Okay. So, yeah, let's search for name double equals. It's a lot. It's more than I expected. Holy crap. Okay. It's fine though, because we're just gonna replace them. So we're just gonna make a procedure called inline bool compare atoms. And right now it's just gonna say return A is equal to B, because we're not actually changing anything yet. We're just trying to catch all our cases. All right, so we're going to go down all these cases of name double equals. Actually, let's say, because compare atoms is vague, let's say atoms match, right? Because now we're saying, okay, true if they match, false if they don't match. Whereas compare atoms doesn't really tell you what the return value is very much. If this is where I really could use, oh man, I just hate trying to type. Look at this, just stop highlighting things, leave me alone. Stop doing auto parentheses, stop popping up crap on my screen. Jesus. All right. At least it's not deleting the name anymore. They fixed that. Although who knows, maybe last time I thought they fixed it, it started happening still in weird cases. All right. We've got like 50 of these. How's it going, everybody? I'm going to be bored to death typing in this horrible editor. The reason I'm using this horrible editor is because it has the search that I could use very easily, whereas in Emacs, I just can't, yeah, I can't deal with Emacs enough to figure out how to do this in Emacs. So, however, for something like this, where it's several in a row, it's just going to be faster anyway. Thanks, Emacs, for ruining my indentation. Okay. Okay. So, we're just doing this over and over. I want to do like a code refactoring tool in the new language where you just like can do this kind of stuff automatically. I know like Super Java Beans Net Enterprise systems have that kind of stuff. Oh, this is commented. The big problem is just somebody could type this later and not use compare atoms and not know that it's wrong. I'm gonna change the ones in comments anyway, just to make that clear. Like I don't want someone resurrecting old code. Visual Studio doesn't have that for C#. You've got to make a regex to do this kind of basic refactoring. Dude, I tried doing a regex yesterday. I won't go into what it was. Maybe we'll do it on stream later because it still has to get finished. But there was something I wanted to replace, and there were 1,050 instances of it in the code. And I was like, okay, I'm not doing this by hand. So I started trying to figure out regular expressions that would get it most of the time. And it was a huge mess because they're not aware of the language syntax at all. So you can't say match on an individual statement. You're just like matching on the file. So you have to manually check for like new lines and stuff all the time and indentation and whatever and try to match your pattern. And I would often screw it up and misfire it, and then you type in a really complicated regex, and then it'll happily highlight something else and kill that out of the copy buffer. And you're just like, I spent 5 minutes coming up with that, and you just threw it away. It's terrible. This whole program is terrible. Yeah, it's... So I managed to get about 700 of them. So I still have 300 of these things that maybe I have to go do by hand. I don't know. Right, that's the thing is people say, why don't you have an IDE? It's so... You need to use an IDE to be productive. And I'm like, what do you think the IDE does for you? It doesn't actually do anything useful for... The one thing that this does for me as an IDE, so as a debugger, it's useful because you can do regular debugger things, but that's the debugger. As an actual IDE, all it does is I could right click and go to definition. That's literally the only thing. Oh, I could also very, very rarely at the top of a file, I could say open this file. That's all I use this thing for. Yeah. Okay. How many million lines of code is it? And how much disk space does it take? And how long does it take to install? And how badly does it frag out your drive when you install it? And that's all it does is you right click and say go to declaration. And it pops up lots of fruit salad boxes to confuse you while you're trying to type. Great, guys. Thanks. Thank you. And it erases your settings all the time when you update your settings. Whoops. I was in the wrong program. Yeah, I'm worried about this because you can introduce a bug just by comparing these accidentally with equals, and I'm not sure what to do about that. Again, in the new language, you could just put something in your metaprogram that compile time faults if somebody does that, but here I don't know what to do. $51.08. Oh, it also does search in files. That's the one thing it does. I just got done saying that's all it does. Actually, it'll search in files. Fine. But to pay for that, I have to maintain all the files in here, which is annoying. So I don't know if that's worth it. Especially since I could use bear grep and it's fine. Yeah, people are just, they have some idea that IDEs are so amazing, but I've never seen one that did more than like 3% of what I actually want it to do. But maybe again, if people are intimidated by programming, then maybe they actually want things to stand between them and being able to program so that they have an excuse. I don't know. Like, I don't like it when things get in the way, it get between me and programming. You know? I want something that stays out of my way, except when it can definitely help. And people who make these programs don't seem to understand that. IDEs are usually pretty customizable. Customizable to do what? To do what? I can't customize this to do what I want it to do right now. To not be annoying. Okay, and then I do that, and then we need to update it, and it resets my settings. Or I need to go to my work computer, and the settings are different, and I can't copy them easily, right? No, I'm done trying to change settings on Microsoft programs because they don't respect me. So, yeah, that's just, no Microsoft program gets me to bother changing the settings anymore. Do we have an aliasing problem like C? We have not thought enough about aliasing yet. So the short answer is I'm not even sure. We might actually, we pass large things by reference. So we might actually have more of an aliasing problem in C if you pass large things by value in C, but people are not really in the habit of passing large things by value in C. They usually pass them by pointer, in which case it's the same aliasing. So, we just have to do like an aliasing lab at some point and just sit down and think hard about it, and we haven't done that yet. Okay. Am I against autocomplete altogether, or is it just personal? I'm not against autocomplete. It's just, it's usually not that useful. That's all. It's usually not that useful because the thing is, so all these autocomplete methods, even when they're good, which the Visual Studio one isn't good, autocomplete requires visual feedback between you and the program to like see what it's trying to complete to, and then you go to the thing and then go, which that becomes worth it when you're typing something really long. But for stuff that's not really long, there's a lot of value to not have to enter that kind of feedback loop, to just like plowing forward, right? And because it's faster, your flow doesn't get interrupted. You know what I'm saying? You just go. You don't have to deal with uncertain inputs. So, yeah, I just don't find autocomplete be that good. I guess if you type not that fast, it's proportionally more helpful. You might want to actually invest in making a Clang analyzer. It will probably save you time by saving you debugging time, and if not, pay for itself in the future. Yeah, I believe that may be a good idea, like especially for something like this, right? Like it's just a rule now in this code base that you shouldn't compare two atoms by equal. I don't know how to do that within the regular parameters of what's available here. So, doing a Clang analyzer might be the thing. Let me even write that down. Like, what would we put in a Clang analyzer? Atom equal forbidden. I don't know what else right now, but I'm sure some things will come up. And if we get a long enough list of things, it might well be worth doing. You had to go through an entire template line by line to find the problem. Well, that might be a template problem, not an autocomplete problem. The way 4Coder does autocomplete, you must explicitly press tab and it will complete its first guess. Then you can repeat tab and it will cycle through its other guesses. Yes, that is the good kind of autocomplete. one that doesn't bother you until you ask for it, right? And one that won't, like Subversion autocomplete will frickin', if you start typing a word and hit enter, because you want to type that word and hit enter, it'll fucking substitute something. It drives me bananas. It's so pompous, right? So that version of autocomplete that you just mentioned is the good kind. And that's actually what we have in our game console, right? You hit tab, or actually everywhere in the editor. You hit tab, it'll complete on the first thing that it can do. It shows you the completion on the end of your string, like in a different color, like animated. And then as you tab, that animated part changes. And then you hit enter on the one that you want, right? But yeah, don't give me autocomplete unless I ask for it, please. Please. Could you use your parser to scan your code every time you compile for 2 atoms? Could I use our parser? Well, we don't have a C++ parser. So no, I can't. That's what someone was suggesting building a Clang analyzer for, was so that we could do that. Is there going to be a warning on the stack size limit? What do you mean? What stack size limit? You're not really sure why equals on atom being a mistake is such a huge deal. If you compare 2 int pointers and they are different, then doesn't that mean that the values are necessarily different either? No. It does mean that right now, that there's a global atom table, but later it will not mean that. That's the whole point. Like later, you could have 2 different atom pointers with the same values inside. So, yeah. That is the whole banana bang shabam. Shabam-a-lama. Okay, we're going to search for name equals again. Okay, we didn't miss any. So now we're going to look for all these names. So let's look for sleeping on atom and make sure that we got it. That's an assignment. Oh God. This is bad. This is bad. I forgot about this. We're going to have to do this. Oh God. Okay. This is a different thing. So what that is, if you try to look up an identifier and it's not ready yet, then you can't figure out the type of your expression. Say it's just a procedure and you're trying to use a global variable and that global variable isn't ready yet. So what you do is you set sleeping on atom to be the atom of that global variable. All right? And then when somebody else goes to declare that global variable, they signal anybody then who's sleeping on that atom that they could wake up now because it's defined. Okay, but that kind of requires that when you declare it, you're able to look up this same atom. So there might need to be a global atom table that's only used for sleeping or something. I don't know, dude. In which case, I'm not sure how much that helps. We're going to have to think about that. But we're going to finish this task that we're doing right now. Why use null, not null pointer? Because why? Who cares? Who cares? All right, let's start searching for these. Entry, point, atom. Make atom, atoms match atoms, strings match. Make atom, make atom. Find declaration helper. Oh, not equals. I forgot to search for name not equals. Not that many, but there are some. Always search for not equals. A good thing we don't have a spaceship operator to check. It's like, just shut up. Don't, why are you, yeah. This editor is so annoying, bro. Like, yes, I know it feels so sluggish because it's going off and computing that it should put these red squigglies under these things that are only going to matter for a half a second because I'm in the middle of something and don't want to have fruit salad in my face while I'm trying to do something simple. Like, I understand why they had the idea that they should have instant feedback like this. It's a little bit of a utopian idea. Hey, look, I use null pointer. Look, null pointer. Somebody else probably wrote this. Yeah, I didn't write this. Actually, that's just checking it for null anyway, so we don't want that. Okay. How is immutable handled? Well, you can declare things as constants, but we don't make really heavy use of declaring things as immutable right now. Maybe we will later, but it's not an emphasis of the language. Except right now, and because we pass anything larger than 8 bytes by reference, procedure parameters that are bigger than 8 bytes are immutable by default, which is a little bit of a weird rule. It's fine when you get used to it. It's maybe inconvenient sometimes, so we might think about changing that. What's my opinion on compiler-enforced tagged unions? I haven't thought enough about it. So far, it hasn't seemed to be worth the complexity, even just as a user. Because I don't, like, again, the question is, like, what is the problem that's trying to be solved? And I don't really have a problem. Like, we've been working on the Sokoban game for 2 years now. I haven't had a bug due to not having compiler-enforced tagged unions. So I'm not sure, whereas it sounds nice, I'm not sure that it's that useful. But it might be. Like, there might be some situation where something is a lot easier to do, or a lot easier to think about, and so forth. So I'm not saying we won't do it. I'm just saying that we haven't thought about it that much, and the little amount that I have thought about it, I haven't seen a big benefit. Is it a general rule that you can't reassign function parameters, or just if it's larger than 8 bytes? Right now, it's just if it's larger than 8 bytes. I'm not sure if that's a good rule. It seems a little bit impure, but in reality, it's practical, so I don't know. What is my long-term plan with regards to editors and IDEs? Well, I don't like IDEs in general. Our version of something like an IDE will be more like a program visualization workshop. Because we don't, you don't need something that you have to redundantly put all your files in. The language handles this, right? So you don't need this part. You don't, I mean, you probably have an editor that you like better than Visual Studio, so why are you using this part? So really the valuable part of this is a debugger. So if you want to use whatever debugger you want, that's fine. When we start doing stuff, it'll be in a direction people don't typically go. We won't be me tooing, well, you can't use the phrase me too anymore in that way. We won't be redundantly doing the same thing as an also ran. Like, we're not going to be like Linux GDB front end wannabes or whatever, right? We're going to be doing our own thing. All right. So compiler still runs. Shouldn't be any different. We just did things with an inline. You assume I won't be doing some Microsoft Language Server Protocol stuff. No, we will not. I will not. I'm sure somebody out there will do it, but it will be our official stance that we laugh at you if you do that. We might laugh quietly, like out of the side of our hand, but that is the official stance, okay? Our community guidelines are be nice to people in the community, be welcoming, you know, don't be mean, don't be nasty, don't be discriminatory. But if somebody uses language server protocol, you're allowed to laugh at them a little bit, just from the side, like tee hee hee, just like this. Not too loud, but just, we'll have a picture of like how much you're allowed to laugh. Okay. So here's the thing. This whole sleeping on Atom makes this whole situation much more fraught with peril than I thought it would be. Because we either need to still have a global Atom table and reduce the degree to which it's used somehow, or we change the way sleeping on Atom works. Like, maybe there's just an Atom table for global declarations, and we say wake on that, or, you know, for top level-ish scopes. So like a file scope is top level-ish. A global scope is top level-ish. So for top level-ish scopes, maybe they just have an Atom table, because we have to synchronize to put things in the oh. Maybe we just, okay. Maybe we have local Atom tables for, maybe everybody's local Atom table is authoritative for that equivalent of a compilation unit. We don't really have compilation units, but we do have like parse units, right? So if you're putting something in a particular place's global scope, this could get hairy. I'm a little bit scared. And then there would be one such Atom table for global variables. For the well, I mean, like if you add strings, this is starting to sound plausible, but I kind of want to think about it for a bit. Will I implement HTTP request or CGI as some utility? Well, there will be a library that you use for that kind of thing. You know, I mean, it's certainly not a compiler level thing, but you know, we already have some libraries for like source control and sending emails. I think we made one. So yeah, that'll happen. Okay. There won't be a run my idea procedure. I'm gonna get a drink, and let's check this in, and I'll get a drink, and we'll think about whether this is really. I feel like it's okay. Because we have places to put these things, like the load directive. So there's a thing called a load directive that happens anytime you load something, even if it's just a string added to the program, right? And every syntax tree node, I believe, has a pointer to its load directive. And every scope knows what the current load directive is. So when we add something to a scope, if it's a top level-ish scope, we should be able to use that moment and that moment only to synchronize on the Atom table for that scope only. It sounds plausible. And that should reduce the amount of work that we have to do. It's just a little bit scary. Because we have to do, the thing that makes it scary is we have to do two things at once, right? So one, well, we don't. We could do that. We could do that structurally, what I just said, but still have them all be pointers to the global Atom table. That's a little weird, but we could do that. And then switch it over. Seems plausible. All right, let me get a drink, and then we will forge onwards. Onward. Actually, we could do a slightly different thing. we could, all that sleeping on Adam thing is just a way of waking people up when something gets declared. So like there could be a table just of these are the atoms that we're sleeping on. They don't even have to be the same atoms. You know, I think the only time this can happen is in the global scope. So I think we can special case it. Like inside a file. I mean, maybe this will change. We want the ability to add strings into specific file scopes, I think, eventually. Oh, no. Also, you could have a using inside a file and the using hasn't run yet. And when it does run, it binds a bunch of names. So yeah, we have to do this in any data scope. What a pain. What a pain. So I do kind of like the idea, though. We're just going to start working toward this structure, and we're going to see what problems we run into. So again, the overall goal is just that we're trying to reduce synchronization between threads. That's all we're doing. So I think we get rid of that cached atom table. That might be too big of a step. In any case, we put it on the load directive. That load directive has the canonical thing. It's been, you know what? We should run tests here just to make sure we are not screwed before we go into this. Just to make sure. We might have made some goof. And when we're about to go into something that's a relatively bigger change, we want to make sure we're on firm footing. Okay. Woo, woo. We got to debug those particles at some point. I don't know. It's recent that they started not really showing up consistently, and I'm not sure what's going on, frankly. There are many more tests than there used to be, by the way. That's why it takes longer to run them. The end goal is not getting rid of the atom tables altogether, but to get rid of them being global. So there will just be a table per load directive that is authoritative over that load directive. Okay, so we're going to start. So the Lexer has this cached atom table. And we're actually going to put that onto the load directive. Actually, we're going to need mutexes as well. Okay. During parse time, we're never going to use the mutex because it's like private. But then after we're done with parse time, then anyone later who wants to add has to take the mutex. And I think right now we have a global mutex for namespaces. Well, there's a global namespace mutex. Oh, because right now you can't. Right, and there's an atom table mutex. Okay. That's going to change. All right, so it's so weird that we're putting this stuff on the syntax tree node. It's a little bit not great, but you know, this is how we're doing it. It's a little weird to have this on the directive load, but this is how we do things downtown now, I guess. So we have an atom table. Okay, that's going to be not great for small things, but we deal with that later. Dude, my computer's having a cow. It doesn't sound like moo, though. It sounds like a fan going crazy. Is it made with data-oriented design in mind? Yes, it is. Yes, it is. Okay. Dude, I'm worried. This computer. Oh my God. I wonder if I need some BIOS updates. Or yeah, we'll check that later. Why is it not a Lisp? Because it's 2019, son. Hope I've got backups. Our source control is our backup. You write Lisp every day in 2019. My condolences. Check resource monitor. Let's look here again. There's really nothing. I think it's just fan problems, right? Is there like a resource? Yeah. Yeah, like, I mean, I don't even know why these CPUs are at 5% or whatever they are, but or 10%. It's actually a lot. Like, why is Microsoft Edge running? Oh, it's suspended. Microsoft Photos, great, thanks Microsoft. I'm glad that's loaded. Yeah, OBS is, oh, it's using different CPUs in turn, I see. Telemetry, let's close telemetry for a bit, just in case. I mean, I don't see any obvious hogs aside from OBS. System interrupts, deferred procedure calls. Why is Creative Cloud still there? Die! 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 Alright. Well, there's no obvious mega hog. Overview tab is better because you can see disk 2. Network. Ah, we're burning up the network. I don't know, man. Do I have a different quality setting for programming? I don't, but I would expect that it's not spending that much bitrate, but I guess it is. I'm not going to worry about it right now. We did our looking and didn't find anything. All right, so all we're going to do so far is I'm kind of feeling like I want to take a break and maybe go outside in the sun. So what we're going to do is, do I have I do have current load directive. So cached make atom can do that. So maybe I'm just going to have a very low assert current load directive. All right. Cached atom table, undeclared identifier, line 71. atom table should, I don't know. This is kind of hard to read right now. This is real low-hanging fruit. Shouldn't really change anything. And then I'm going to take a break, and we'll probably come back later and work on this, because this is going to require a little bit of brain power. And we've already streamed for 6 hours today, or 5. Ooh. Ooh. Are we like not... Oh, we never called init on our atom table. That's the thing. Yeah. I don't exactly feel like this is the right place, but we'll do it anyway. Let's tag this one as a... Alright. Hey, okay. Well, we didn't really change anything. We're just moving a couple things around. We're not doing anything complicated yet. Like, we literally didn't change anything hardly. Not literally, but we didn't change anything hardly. All right, thanks everybody for coming by. I'm going to take a break. We'll probably do another stream later today where we dive further into this. But first, we'll go find someone to raid. We will continue the atom table privatization at a later time. Rip, your question. What was your question? Let's find a science and technology streamer. Not drunk. We don't do drunk programming. I need some amateur self-teaching builds PC to make my PC stop being loud. Working on an app for fun. Reasonable coding, that sounds good. Let's see what reasonable coding is. It says web, that scares me. What is .re? This doesn't look that reasonable. Oh, it's a lispy thing. I don't know. I don't know who to host. Late night stream. It's just so hard to find people. The Godot guy, maybe. This one?
Ranged.
I mean, really?
And then we are going to connect entered.
You know what? I think maybe we don't raid. What Tetris one? Let's see. Maybe we don't raid today. Programming Tetris with the code I use for my library, part 2, the actual game. That could be good. All right, let's do this. Thanks everyone for coming by. We will continue later.
Okay.
And continue with this scary atom table thing. Thanks for visiting.
There we go. I'll do it like this. And not set the correct wording.
Bye.